Today's class is on fractions and decimals. Extremely important topic. Extremely important topic for all aptitude exams. For all aptitude exams. Very important topic. I request each and every student's help to share this class link which was sent to your WhatsApp to as many students as possible. Extremely important topic. As usual, we will discuss concepts, we will discuss shortcut tricks, no traditional methods, shortcut tricks, no traditional method. If any student is looking out for any traditional formula based method, I am sorry, I will not be able to meet your expectation. All my YouTube live classes are very conceptual and it discusses the why behind the answer, why that answer is incorrect more than just doing the answer. Right? Now before we start the class, very important information. Any student who is listening to the class for the first time because of your friend's reference, kindly WhatsApp to this number to get all the class updates. Kindly make a note of this class. Our WhatsApp number 8296989020. Through this WhatsApp number you will get all the class links or any of the exam notification or any of the class PDFs. Any student who missed the yesterday's session, if you want the class PDF by 2 o'clock, you will get the class PDF from this WhatsApp number. In case if you want the class PDF effective from tomorrow, on the PPT I will annotate, so I will try to give you the solution key as also as a part of the PDF, but that will not be helpful because only steps are there. Kindly WhatsApp this number, that is the first key point. In case you got any doubts in any of the class, this is our email ID, support@anilnayarclasses.com. Faculties will look into every day this email and they will answer your doubts. support@anilnayarclasses.com. Why these YouTube live classes? What is that we are trying to achieve because of the YouTube live classes? It helps us to eliminate the use of pen or pencil and it helps a student learn the concepts logically. It helps the students to know beyond just a formula based lecture. Do not skip in between. If you are sitting at the beginning of the lecture, kindly listen to the entire lecture so that most of the concepts will be covered. And best way to learn my class is to take a notebook and a pen or a pencil and make a note of all the concepts. Take a notebook and a pen or a pencil. As and when I am discussing a concept, write down in your notebook. Nothing beats other than the handwritten notes. Nothing beats other than the handwritten notes. The best way to learn any concept is to develop a handwritten notes. Shall we all start the class? Kindly reply it in the live chat. Should we start the class? Kindly reply it. Shall we start the class? I want each and every viewer to reply it in the live chat so that I can start the class. So this is about me. More than 1,000 students. I might have taken session more than 500 times. So pay ultra attention to the lecture. These concepts you will not find it in the regular textbook. Shall we start the class? So we will start the class. Please write down heading. Few important key points. Which we will discuss. Then we will start the class. Heading, please write down fractions and decimals. First 5 to 10 minutes I will discuss few concepts, 5 to 10 minutes basics, then we will get into a problem solving. 5 to 10 minutes basics which we will discuss, then we will get into problem solving. Now listen carefully to the basics. First one, please write down. First one, before we start with the fractions and decimals, first let me discuss what is a natural number. Natural numbers. Natural numbers. Natural numbers are nothing but the numbers which can be counted, or the numbers which can be counted are called natural numbers. The numbers which can be counted, numbers which are used for counting, are called natural numbers. Natural numbers are from 1, 2, 3, 4 and so on. The numbers which you can count it, there are 2 pens, there are 5 pencils, there are 4 bags, there are 5 people, there are 10 animals. Anything that you can count it is called natural number, are called natural numbers, are called natural number. 0 is not a natural number. 0 is not a natural number. Number which can be counted is called a natural number. 0 means it is not existing. If it is not existing, it cannot be counted. Natural numbers are called as counting numbers, and it is denoted by capital N. And it is denoted by capital N. Natural numbers are called as the counting numbers, and it is denoted by capital N. After that, the invention of 0 has resulted in a new numbers. Invention of 0 has resulted in a new number. That numbers are called whole numbers. That numbers are called whole numbers. Whole numbers. Whole numbers is nothing but natural numbers. Natural numbers is 1, 2, 3, 4 with 0 addition. With 0. With 0 addition. Natural numbers will start from 1, whole numbers will start from 0. Write down as it is the way I am saying it, because each and everything whatever I am saying it will be useful for problem solving. Before we discuss what is a fraction, we are discussing what is a natural number and what is a whole number. Natural numbers are called as counting numbers. Whole numbers are denoted by W. 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 First slide, I hope it is clear. Natural numbers and whole numbers. Next slide. Now, then came integers. Then came integers. What do you mean by integers? These integers came because of the invention of positive and negative numbers. Positive or negative numbers. Positive or negative numbers has resulted in set of integers. Integers is nothing but negative, next is 0, and next is positive. -3, -2, -1, 0, 1, 2, 3. And so on. Negative numbers, positive numbers and 0 are called as integers. Or in simple words, integers is nothing but negative natural numbers, positive natural numbers, positive natural numbers and 0. Negative natural numbers, positive natural numbers and 0, all three combinedly are called as integers. Natural numbers are the numbers which can be counted. Invention of 0 has resulted in a new set of numbers which we call it as whole numbers. Then came negative, 0 and positive. Then came integers. I hope it is clear. Next one. One important point. 0 is neither positive nor negative. 0 is neither positive nor negative. 0 is neither positive nor negative. Positive integers. Integers which are positive. Positive numbers means which can be counted. They are also called as natural numbers. Positive integers are also called as natural numbers. Positive integers are also called as natural numbers. Non-negative integers. These are synonyms. Non-negative integers are also called as whole numbers. Whole numbers. Please make a note of this. In the questions, maybe the terminology might be, instead of saying whole numbers, they might ask you how many non-negative integers are same. All are non-negative integers means whole numbers. Non-negative, other than negative. Integers is negative, 0 and positive. Non-negative, other than negative. That means 0 and positive. Positive integers are called natural numbers. Non-negative integers are called whole numbers. First we discussed what is a natural number, then we discussed what is a whole number, then we discussed what is an integer. Now we will get into our topic. Next is fractions. This is our topic of discussion today. Fractions. Fraction means anything which is a part of 1. Anything which is a part of 1 is called fraction. Anything which is a part of 1, which is a fraction. Right? Suppose if I say 1 by 2. 1 by 2 of a part of 1. 1/10 of a part of 1. 2/3 of a part of 1. 4 by 7 of the part of a 1. There could also be some fractions where numerator is greater than the denominator. 15 by 4, which is in mixed fraction is 3 by 4. That means 3 parts and 3/4 of a part of a 1. 3 and 3/4. So if you observe in the fractions, anything which is a part of a 1 is called a fraction. Anything which is a part of 1 which is called a fraction. Now in fractions, there are two kinds of fractions are there. One is a proper fraction. Another is an improper fraction. One is a proper fraction, another is an improper fraction. A fraction will have numerator and denominator. NR refers to numerator. DR refers to denominator. There are fractions, there are two parts are there. One is proper fraction and another is improper fraction. Proper fraction and improper fraction. Proper fraction means the value will be less than 1. Value means a fraction is of the form numerator by denominator less than 1. Numerator is nothing but less than denominator. A proper fraction is a fraction where numerator is less than denominator. A proper fraction is a fraction where numerator is less than denominator. Improper fraction means it is greater than 1. That means numerator by denominator greater than 1. So this is nothing but numerator greater than denominator. Improper fraction means numerator greater than denominator. Proper fraction means numerator less than denominator. Improper, which is not proper means which is not numerator less than denominator. So other case is numerator greater than denominator. Proper fraction means numerator is less than denominator. Improper fraction means numerator is greater than denominator. Again in a new slide I will write it. Just write in the same way, sir. In the proper fraction, what is the definition of a proper fraction? Fraction is less than 1. That means numerator is less than denominator. Few examples where numerator is less than denominator. 2 is less than 3. So 2 by 3 is a proper fraction. 7 is less than 10. 7 by 10 is a proper fraction. 5 is less than 8. 5 by 8 is a proper fraction. 5 by 8 is a proper fraction. Right? What is improper fraction? Improper fraction means which is not proper. Numerator and by denominator greater than 1. That means numerator is greater than denominator. Greater than denominator. Examples are 7 by 2. 7 by 2. 7 is greater than 2. 5 by 4. 5 is greater than 4. 13 is greater than 10. 13 is greater than 10. All these improper fractions can be written in a mixed form. Mixed form means they can be converted into a proper fraction. For example, 7 when divided by 2, 2 3s are 6, it is 1 by 2. So this is nothing but 3 1 by 2. 3 1 by 2. 3 1 by 2. If you observe, this is nothing but dividend. This is nothing but dividend. This is nothing but divisor, number which is dividing. This is nothing but quotient. This is nothing but remainder. So, any improper fraction can be written as quotient, remainder by dividend. Why? Because dividend is divisor. So it is nothing but dividend is nothing but divisor into quotient plus remainder. Divisor into quotient plus remainder. Make a note of it, sir. In improper fraction can be converted into a mixed fraction. In the mixed fraction, dividend is nothing but divisor into quotient plus remainder. So 3 1 by 2 is 3 2s are 6, 6 plus 1 1 by 2. 5 by 4 is 5 1 by 4. Proper fraction, numerator is less than denominator. Improper fraction, numerator is greater than denominator. Numerator is greater than denominator. Now, one important observation in proper fraction which will be extremely useful in our DI. Proper fraction. A proper fraction is of the form numerator by denominator which is less than 1. Suppose if denominator minus numerator, if it is same, if denominator minus numerator it is same, 1 by 2, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. Right? Simple. Lowest numerator, as the numerator increases, the value will decrease. In a proper fraction, the fraction increases, the fractional value increases as numerator increases, as numerator or denominator increases. Extremely important point. Please make a note of it, sir. In a proper fraction, what do you mean by a proper fraction? Numerator less than denominator. If numerator is less than denominator, lowest numerator, lowest denominator will be the lowest value. In simple words, lowest numerator and lowest denominator. Lowest numerator, lowest denominator, the value will be lowest. As long as denominator minus numerator difference is same. What if it is not same? That also we will discuss. This is in proper fraction. Every concept which I am explaining at the beginning of the class, it will be useful as the class progresses. You will see some important concepts which I am using. Proper fraction, numerator is less than denominator. In proper fraction, lowest numerator, lowest denominator, the value will be lowest. Next point. Improper fraction. In improper fraction, numerator by denominator is greater than 1. If it is greater than 1, simple concept, highest numerator, highest denominator, the value will be highest. value will be highest as long as denominator minus numerator is same. As long as denominator minus numerator is same. We are discussing a case where denominator minus numerator is same. For example, 3 by 2, 4 by 3, 5 by 4. 3 minus 2, 3 minus 2, 1, 4 minus 3, 1, 5 minus 4, 1. Highest numerator. I hope it is clear. Greater than. Or we will write like this. Instead of writing like this, I will write like this. Or I will write like this. Value decreases as the numerator denominator increases. It's a simple point. Value decreases as the numerator and denominator increases. Are you all with me? This is the best way to write it. Value decreases as the numerator and denominator increases. Improper fraction. First one, value will be decreasing. Right? Proper fraction, improper fraction. Next comes the most important concept for today's class, rational numbers. Rational numbers is derived from the keyword ratio. Ratio means anything which you can write it in fraction format. Any number which you can write it in the form of P by Q. P and Q are integers. Q not equivalent to 0 is a rational number. Rational number is derived from the keyword ratio. Ratio means you have to write it in a fraction format. Any fraction format will be of the form P by Q. P and Q are integers. All integers are nothing but rational numbers. All integers are nothing but rational numbers. 2 can be written as 2 by 1. It can be written as 4 by 2. It can be written as 6 by 3. It can be written as 8 by 4. A rational number is derived from the keyword ratio. Ratio means fraction. So a fraction format will be P by Q. Q not equivalent to 0. Q not equivalent to 0. I hope it is clear. Now comes the very important table. There are integers. There are decimals. I'll write like this. There are integers and there are decimals. This combination is nothing but rational numbers. Integers is a rational number where the denominator is a factor of numerator. In decimal, there are two varieties. One is a terminating decimal. Terminating means which stops. 0.23, 0.78. These are all terminating decimals. Next is non-terminating, which does not stop. Non-terminating decimal. Terminating means which terminates, which stops after at a point. Non-terminating, which does not stop. Now which does not stop means again two varieties. any digit will it be repeated, recurring of digits or repetition of digits. Non-recurring. Non-terminating means which does not stop. Recurring means, for example, 0.343434. 34 only is getting repeated. 34 only is getting repeated. Non-recurring is 0.123567342 and everything. There is no digit which is getting repeated. So again I am saying, in decimals there are two types: terminating, terminal, terminus. Terminating means which stops after a time, which stops after at a particular time. Non-terminating means which does not stop after a time. Which does not stop means which will keep continuing. If it keeps continuing, are there any digits in that decimal which keeps repeating? There are no digits which gets repeating. If they get repeated, it is called recurring. If it does not get repeated, it is called non-recurring. Extremely important. Today the entire class is on recurring, terminating and non-recurring. The entire topic will be based upon this one. In rational numbers there are integers and decimals. In decimal, terminating and non-terminating. Non-terminating, it will not stop. So if it does not stop, what will happen? The digits will keep continuing, or same digit will keep continuing, or different digits will keep continuing. Same digits, if it keeps continuing or if it keeps repeating, it is called recurring decimal. If it does not get repeating, it is called non-recurring decimal. Non-recurring decimal. I hope you are all there with me. Again I will discuss the last slide. Terminating decimal. After this we will get into problem solving. Terminating decimal. Terminating, which terminates 0.12, 0.784, 3.416. These are all terminating. Recurring decimals. Digits will be repeated. 0.33333. 3 is getting repeated, which is called 0.3 bar. 0.3 bar. This is nothing but a pure recurring decimal. Suppose if it is 0.234234, which is nothing but only 34 is getting repeated. So it is whatever the digits that is getting repeated, on that keep a bar. This is nothing but a mixed recurring decimal. One digit has stopped and 34 is getting repeated. What is non-recurring? Non-recurring, it is not stopping but with different digits. There is no particular pattern. In recurring decimal, there is a pattern of digits getting repeated. Pattern of digits getting repeated. Pattern of digits getting repeated. That is a recurring decimal. Pattern of digits getting repeated. Non-recurring, there is no particular pattern. There is no pattern. There is no particular pattern. There is no pattern. If there is no pattern, write, for example, 0.123789235 there is no particular pattern. In recurring decimal, there is a pure, only few particular digits are getting repeated. After dot there will be some more thing. Are you all with me? Recurring is kept by a bar on the digit which is getting repeated. On the bar which is getting repeated. Another important observation. Left of the dot, if there is a bar which is nothing but minus a plus point bc. Suppose 2 bar dot 53, which is nothing but minus 2 plus 0.53. This I will discuss in detail in logarithmic chapter when I discuss a mantissa concept. We will discuss this. Dot can also be there to the left of dot. After dot, that means it is to the left of dot also it could be there. A bar dot BC is minus A plus point BC. Minus A plus point BC. Last one. What is last one? Irrational number. Irrational number. Irrational number. Irrational number. Irrational means which is not a rational number. Which is not a rational number. Which is not a rational number. Which is not rational number. Numbers which are not rational numbers. What is a rational number? Which can be represented in the form of P by Q. Which cannot be represented in the form of P by Q. Which cannot be represented in the form of P by Q. Which are not terminating. Which is not terminating. The symbol is for not. Which are not terminating. Which are not recurring. So it is nothing but non-terminating. Non-terminating. Non-recurring values. Any number, if it cannot be represented in the form of rational number, are called irrational numbers. Irrational number cannot be written in the form of P by Q. First point, irrational numbers are not terminating. Irrational numbers are not recurring. Irrational numbers are not recurring. Irrational numbers are not recurring. Now in irrational numbers, classic case of irrational numbers. Classic case of irrational numbers. Classic case of irrational number. Pi is an irrational number. E is an irrational number. Phi is an totient function. It is an irrational number. Phi, E, phi, right? These are all irrational numbers. Root 2, it is an irrational number. Root 7, it is an irrational number. Root 9 is 3. 3 can be written as 3 by 1. Root 9 is an rational number. Root 9 is an irrational number. Almost all the constants which we use in maths and physics, whatever the constant that we use in maths and physics, almost all the constants are nothing but irrational numbers. All the constants are nothing but irrational number. I hope it is clear. Till now we discussed the basics. Now we will get into problems. Real numbers is nothing but rational numbers plus irrational numbers. Rational numbers plus irrational numbers. Rational numbers plus irrational numbers. Real numbers is nothing but rational numbers plus irrational numbers. I hope it is clear. I hope it is clear. Right? Till now, is it clear? Or if you want a clear clarity on the table, the superset of all the numbers is real numbers. Superset of all the numbers is real numbers. Real numbers is nothing but a combination of rational numbers and irrational numbers. Rational numbers and irrational numbers. Irrational numbers are nothing but numbers which cannot be in the form of P by Q. Pi, root 2, cubed root 3, fifth root 7, E. All these are irrational numbers. Pi is approximated to 22 by 7. It is not equal to 22 by 7. So pi is an irrational number. In rational numbers are of the form P by Q. In that one, two types. What are the two types that we discussed? Next, first it is integers. Next it is fractions. Next it is fractions. In fractions, what we discussed, a fraction can be written in the form of a decimal. Fraction can be written in the form of a decimal. So in decimal, what we wrote, one is terminating and the next one is non-terminating. Next one is non-terminating. In non-terminating, what we wrote? It could be recurring or it could be non-recurring. It could be non-recurring. It could be non-recurring. In integers, what we wrote? Whole numbers. Whole numbers and negative integers. In whole numbers, there is natural numbers. In natural numbers, there is prime number and there is composite number. In natural number, there is prime number and there is composite number. I hope the table is clear. I hope the table is clear. Till now, any doubts? Now we will get into a wonderful problem solving. Wonderful problem solving. Till here, real numbers, rational numbers, irrational numbers. And if you do not understand this basic difference of what is terminating, what is recurring, now the next slide will give us foundation to solve the problems. I hope it is clear. Note, please write down, sir. Note. Now here onwards, the intermediate level questions will be used. Note, first point, digital sum is used. When to use digital sum? Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimals. Digital sum is used only for terminating decimal. Second point, digital sum is used when the denominator is either a power of 2 or a power of 5 or powers of 2, 5 both. Extremely important points. Please make a note. Digital sum is used only when the denominator is either a power of 2 or a power of 5 or a power of 2, 5 both. You cannot use digital sum in fractions where the denominator is any value other than 2, 5. That is the reason a percentage is a by 100. 100 is nothing but 2 square into 5 square. So in percentages, I can use digital sum. I hope, please make a note of it, sir. Please make a note of it. Digital sum is used only for terminating decimal or the decimals where the digits are not repeated, which stops. Digital sum is used only when the denominator is either a power of 2 or a power of 5 or a power of 2, 5 both. First key point. Then you will be able to solve the toughest questions very easily. Power of 2, 5 both. First point, I hope it is clear, right? Second point. Please write down the second point. Then fadafat we can solve the problem. Second point. If P is a prime number, P not equivalent to 2, 5. If P is a prime number, P not equivalent to 2, 5. 1 by P. P not equivalent to 2, 5 means it will not become a terminating decimal. It will become a recurring decimal. with a cyclicity of period of factor of with a cyclicity of factor of p minus 1. Please make a note of it, sir. Please make a note of it. If we discussed what happens if the denominator is only powers of 2 or powers of 5 or powers of 2 comma 5 both, then we have to discuss the reverse case also. What is the reverse case? What if it is not power of 2 comma 5? If it is not power of 2 comma 5, it becomes a recurring decimal. Then if it becomes a recurring decimal, then the digits will be repeated. In what way it will be repeated? It will be repeated in factor of p minus 1. This is derived from Fermat's theorem. A power p minus 1 divided by p, it is 1, where a comma p are co-prime numbers and p is a prime number. This is a derivative from Fermat's theorem. Write down this, then I will explain you the problems. 1 by p. Suppose if you want to know 1 by 7 is nothing but 0.142857 bar. 142857 only will be repeated. 7 is a prime number. So repetition of digits will be in a factor of p minus 1. 7 minus 1 is 6. 6 digits are repeated. I hope it is clear. Till now, all the concepts are clear? I hope all the concepts are clear. Shall we go to problem solving? Shall we solve problems based upon whatever we discussed? Shall we solve problems? Kindly reply it in the live chat. Shall we solve problems? Reply it in the live chat. Shall we solve problems? Shall we solve problems? All the concepts, are they clear? Digital sum is used only for terminating decimal. It cannot be used for recurring decimal. First point, when it will be terminating, when the denominator is either a power of 2 or a power of 5 or the powers of 2 comma 5 both. That is clear. Next, if it is a recurring decimal, now let us discuss the problems. First one. Now see here. Which of the following are? First one. Listen carefully. Identify which of the following are rational numbers. Unfortunately, after the class is over, this class entire video will be present only to the students who buy my latest package, Anil Nayar's aptitude special videos. I am going to discuss 60 to 80 hours of new content, absolutely 2019. I am going to create a separate folder today. Those who purchase it, today's class, within 2 days it will be visible in that folder. Other students who purchased last year, they have to upgrade the package. Thank you very much. Yesterday 85 students have already upgraded these, only because you want to know the content. Now see, identify which of the following are rational numbers. Simple basics. Identify which of the following are rational number. What do you mean by a rational number? Rational number should be of the form P by Q. Rational number can be terminating. And rational number can be recurring. No need of telling answers. I don't need the answer. It can be terminating or it can be recurring. 5 by 9. 9 is 3 square. If the denominator is a prime number other than 2 and 5, then it will be a recurring decimal. A recurring decimal is a rational number. So first one answer is rational. No answers needed. Listen to the explanation. Denominator is a prime number other than 2 and 5. 9 is derived from a prime number 3 square. 0.333. 3 is getting repeated. 0.3 bar. So it is a recurring decimal. It is a recurring decimal. A recurring decimal is also a rational number. A recurring decimal is also a rational number. Root 2. Root 2 cannot be expressed in the form P by Q. Root 2, it cannot be expressed in the form P by Q. Third one answer is irrational number. Third one answer is it is an irrational number. Third one, it is an irrational number. 22 by 7, which is in the form of P by Q, where P and Q are integers. 22 is an integer, 7 is an integer. So fourth one, 22 by 7, it is a rational number. 22 by 7, it is a rational number. Pi. Pi is nothing but circumference of a circle by diameter. Pi cannot be expressed in the form of P by Q. Pi cannot be expressed in the form of P by Q. Irrational number. Irrational number. Irrational number. Only write down, listen to the explanation. 0.57357353. It is nothing but non-terminating. It is nothing but non-terminating. It is not non-recurring. Non-terminating, non-recurring decimal. Non-terminating, non-recurring. Non-terminating, non-recurring. Non-terminating and non-recurring. I hope it is clear, right? Non-terminating and non-recurring. So these nothing but five 735. Here 735 is repeated. 735. Oh, sorry. Here it is. Here it is written in the question that it is getting. It is 573 is getting repeated. So it is mentioned. So it is a recurring decimal. It is a recurring decimal because it is written here. I have not noticed this. Recurring decimal. Recurring decimal is a rational number. Recurring decimal is a rational number. I hope it is clear. I have not seen that 573. Next one. F. Next. 563962460666496. Non-terminating. Non-terminating. And it is not, digits are not getting repeated. Non-repeating. Non-terminating, non-recurring. Non-terminating, non-recurring. Which is an irrational number. Which is an irrational number. Root 5 power 100. 5 power half power 100. Which is 5 power 50. 5 power 50 is nothing but an integer value. Integer can be represented as a rational number. So this is a rational number. This is nothing but 5 power 50 plus 1 by 5 power 50. Again a rational number. Again a rational number. Again a rational number. I hope the basic idea it is clear. Non-terminating, non-recurring. I will use beautiful answer options, sir. Just to hold on. From basic, intermediate, advanced, I will discuss as many concepts as possible. Now, see carefully before this. Suppose there are a lot of questions which we will solve. Now, see here, sir. Listen, see this question, 12th question. 8 by 27. 8 by 27. 8 by 27. First option is nothing but 0.296 bar. 0.296 bar. Second option is nothing but 0.296 bar. Third option is nothing but 0.29696. 296 bar. Fourth option is 0.296. 0.296. Now we should know how to convert these fractions. Just let me see. 9 by 14, 9 by 14. Okay, I think conversion is there. I think 14th, 15. 1 minute, sir. I am just want to discuss few good questions before we solve it. Right, we can come from the 20th question. See the 20th question. Wherever the concept is there, I am not going to solve. See the 20th question. Original competitive examination question. Then I will discuss different models at a time. M equivalent to 0.1 plus 0.1 square plus 0.01 square, 0.3 plus 0.03 square plus 0.003 square. Anil Nayar's way of solving the question. Apply digital sum. If I apply digital sum for 1.32 will be sum of the digits till you get a single digit number. 1 plus 3 4, 4 plus 2 6. So apply the digital sum. 0.1 it is 1, 0.1 it is 0.01, sir. It is 1, 0.001 it is 1 plus 1 which is 3. Please make a note. 0.1 plus 0.01 square plus 0.001. N is nothing but 0.3 it is 3. 0.03 square, 3 square 9. Again also 9. If you add the digits to 9 or multiples of 9, digital sum will not change. So M plus N is nothing but 3 plus 3 6. Answer digital sum should be 6. Delete the digits whose sum is 9. 3 plus 3 plus 3 is 9. 1 plus 1 plus 1 digital sum is 3. It is not possible. 3 plus 3 plus 3. 3 plus 3 plus 3. So these is nothing but 1 plus 1 3. These is not possible. 3 plus 3 6. 6 plus 7 7 8 9. 4 not possible. Not possible. Next 9 over 4 plus 1 plus 1 6. Answer for this question is option A. Answer for this question is option A. Option A. Why? Because digital sum is 6. Why? Because digital sum is 6. Why? Because digital sum is 6. This is method 1. This is method 1. Method 1 to solve. Apply digital sum. Question is 0.1 plus 0.01 square plus 0.01 square. 0.1 digital sum is 1. 0.01. The M question is like this. 0.1 plus 0.01 square plus 0.001 square. There is a digit 0 which is missing. So 1 plus 1 plus 1 is 3. 3 plus 9 plus 9 is 3. M plus N is 3 plus 3 6. Answer digital sum should be 6. What if more than one answer option has the same digital sum? This is method 1. Method 1. Now write down method 2. First I am discussing one model. Method 2. Method 2. Method 2. Method 2. Now if you see here, since the series is decreasing, use approximation concept. Use approximation concept. Use approximation concept. What is approximation concept? M is nothing but 0.1. Next it is 0.01 square. Next it is 0.001 square. 001 square. Now see here, these are all very small values. N is nothing but 0.3 plus 0.03 square plus 0.0003 square. These are also smaller values. So M plus N, answer should be just greater than 0.4. Answer should be just greater than answer should be just greater than 0.4. Answer should be just greater than 0.4. Answer should be just greater than 0.4, because answer is just greater than 0.4. Third option is eliminated. Fourth option is eliminated. Now then you can use digital sum. I hope the concept is clear, right? 0.01 whole square is point followed by 3 zeros ending with 1. That is very small. So because the values are decreasing, use approximation. Just by looking at a question, you can say that 0.13 is out. Here n value itself is 0.3 plus something. N itself is 0.3 plus something. How can it be 0.1? M plus n itself is 0.3 plus 0.1, which is 0.4. How can it be 0.3? Third option and fourth option are directly eliminated just by looking at an answer option. Answer options are not only used to tick mark, but also used to eliminate incorrect answers. I hope approximation logic and digital sum logic, I hope it is clear. I hope it is clear. This is one way to solve few fractions and decimals. I hope it is clear. Digital sum. Next one. 19th one. 19th one. Now if you see here, n equivalent to method 1 and method 2. Method 1, n equivalent to 0.369, 369 and so on, which is nothing but n is 0.369 on that one bar. On that one bar, 0.369 is just greater than 0.3 bar. 0.3 is nothing but, even if I take 0.3, which is 3 by 10, approximately, I am approximating the values. I am approximating the values. Approximating. M is nothing but 0.531, which is nothing but 0.531 on that one bar. It is just greater than 0.5. 0.5 is nothing but 1 by 2. 1 by n plus 1 by m. 1 by n is nothing but 10 by 3. 1 by m is nothing but 2 by 1. So it is nothing but 3 point something plus 2. Answer is just close to 5 point something. Answer is just close to 5 point something. 5 point something means numerator is greater than denominator. Am I right? 10 by 2 is only 5. Numerator should be greater than denominator. It is not even close to 5. Simple way to solve. Method 1, approximating. N is 0.369, 0.369. 0.369 bar. 0.369 bar is just greater than 0.3. I don't want to show my mathematics by using that conversion thing. 0.3. 0.3 is nothing but 3 by 10. 0.531 is nothing but 0.531 is nothing but 0.5. I hope it is clear, right? 1 by 2. This is one way to solve. Method 1. Method 2. Please do not use digital sum. Please don't use digital sum, because digital sum cannot be applied for a recurring decimal. One previous question is based on a terminating decimal. Now it is on a recurring decimal. Don't use it on a recurring decimal. Don't use it on a recurring decimal. This is method 1. Method 2. Method 2 I will come back, right? Because I will again come back to this question. I will again come back. This is one way to solve. Now see the 13th I did not discuss. 15th. See 15th logic. Method 2 also I will discuss. I will come back to it after I discuss. Method 2. 0.4 plus 0.44 plus 0.44 and so on up to n terms equivalent to. Another question. 0.4 plus 0.44 plus 0.44444 and so on up to n terms. This is nothing but question contains numerical values. Question contains numerical values. Answer contains variables. Yesterday we discussed the reverse order. Question contains numerical values. Answer contains variable. Question contains a numerical value. What you do is again approximation. Yesterday we discussed one concept, similarity in number system. Do the values for a lower values and check it out whether there is any pattern. Similarity in number system. Similarity. Put n equivalent to 1. N equivalent to 1. Question value is 0.4. Question value is 0.4. Now let me put it in B option. If I put it in B option, 4 by 81 into 9 minus 1, 8, 8 plus 1 by 10, which is nothing but 4 by 81 into 81 by 80, which is nothing but 4 by 10, which is 0.4. 0.4. So it is giving you, first option will not give, third will not give, fourth will not give. 0.4. I hope it is clear. Is it clear? You can also check it out, n equivalent to 2. If I check with n value 2, 4 by 81 into 9 2s are 18, 18 minus 1, 17, 17 plus 1 by 100, which is nothing but 4 by 81 into 4 by 81 into 1701 divided by 100. 9 9s are 81, 9 1s are 1, 80, 9 8s are 72, 189, 4 by 25. You can check it out. You can check it out what is that value that you are getting it. I hope it is clear, right? 921, sir. So 21 by 25. If you do it, you will get it as 0.84. 0.84 is nothing but 0.4 plus 0.4 plus 0.44. I hope it is clear. Just approximate the values. Put n value 1. Put n value 1. See, you don't, just by observation itself, answer will be B. You don't need to do anything. Just by observation itself, answer will be B. If I put n value 1, 70 plus 1 is 71, but it is 71 is not divisible by 9. 81 is divisible. Here it is also 79 is divisible. This should be a multiple of 81 or 81. So these is not possible, these is not possible, these is not possible. I hope it is clear. Put n value 1. This is one model. I hope it is clear. Till now, is it clear, right? Next one. Any other models which we will discuss? Now, which is greatest? Which is greatest? It is nothing but 0.725 000. Next it is 5 is getting repeated. So it is 55555. Again 25 is getting repeated. 25, 25, 25 and so on. Here 725 is getting repeated. So 725, 725, 725. What you do here is, the best way to solve this question is, 7 is common, 25 is common. Take the first digit after 725. Take the first digit after 725. 0527, which is highest, 7 is highest. So 0.725 bar. This is the highest value. I hope it is clear. This is the highest value. This is the highest value. 0.725 000, 0.725 555, 0.725 2525, 0.725 725 725, 0527. Highest is 7. So highest value is 0.725. I hope the idea is clear. Different questions, different way of solving it, the question. You don't need to refer any book. Just sit in my class and start listening to all the concepts. Now, see here. Now, if you see 10 by, okay, this I will solve little later. I need to discuss a concept. Here also I need to discuss a concept. So I think I will discuss that concept, then I will get back. Now see. Let us see. First, convert 0.33333 into a P by Q form. First is method 1, then I will discuss method 2. Method 1, x is nothing but 0.33333. 3 is getting repeated. So multiply with 10. If I multiply with 10, one digit will move, 3.33333. If I subtract, 10x minus x is 9x. 3 minus 0 is 3. 0.33 cancel. So x is nothing but 3 by 9, which is nothing but 1 by 3. 3 by 9, which is nothing but 1 by 3. This is the traditional method. This is the traditional method. This is the traditional method. Now let us look at the method 2, optimal method. Method 2. Listen carefully. Method 2, fast method. How to write the answer? 0.3 bar. Now see, step number 1. After dot, on whatever digits bar is there, that many 9s will be present. So there is 1 9 because bar is present on 1 digit. Bar is present on 1 digit. After dot, what is the number? 3. There is no other digit which is there. So 3 by 9 is nothing but 1 by 3. Directly we will get the answer. I will explain with method 2 by taking more examples. 0.3 bar. I will take more examples. After dot, on whatever digits bar is there, that is nothing but 9. After dot, whatever digits bar is not there, that we will insert 0. That I will take as many examples as possible. 3 by 9 is 1 by 3. Now listen carefully. 0.1212, 0.121212 and so on. This is nothing but 0.12. 12 is getting repeated. So on that one bar. Step number 1. After dot, there are 2 digits. On 2 digits there is a bar. So there will be 2 9s. 99. After dot, what is that number that is there? 12. On any digits is bar is there? No. So 12 minus 0, which is nothing but 12 by 99. 12 by 99 is nothing but 3 4s are 12, 3 33s are 4 by 33. I hope it is clear. 4 by 33. If you observe, 33 is nothing but 3 into 11. If the denominator is any prime number other than 2 and 5, then it gives a recurring decimal. That is what? Recurring decimal. Recurring decimal with a factor of p minus 1. Factor of 3 minus 1, 2. Factor of 11 minus 1, 10. What is the factor common to 2 and 10? 2. 2 digits are only repeated. You can also cross check. 0.121212. On 12 there is 12, it is 2 digits. 2 digits is getting repeated. So it is 0.12 bar. Because bar is there on 2 digits, there is 99. After dot, what are the numbers? 12. There are no digits where bar is there. So 12 minus 0. 12 minus 0. I hope it is clear. After few minutes you will come to know how am I using to solve few questions. Next one. 0.133. This is mixed concept. 1 is terminated, 3 is getting repeated. So 3 is getting repeated. So on that one there is 3 is bar. After dot, whatever digit bar is there, there I will write 9. After dot, whatever bar is not there, I will write it as 0. 9 is based on the digits where bar is present. Digits where bar is present. Where bar is present. 0 is based upon the digits where bar is not present. Digits where bar is not present. Where bar is not present. Where bar is not present. After dot, what is the number? 13. Subtracted from the digit where bar is not there. So minus 1. 13 is the number. 13 is the number after dot. 1 is the digit where bar is not present. Bar is not present. I hope it is clear. where bar is not present. We will do as many examples as possible, then it will be clear. After dot, on whatever the digits bar is there, write 9. Whatever the digits bar is not there, write 0. 12 by 90. Now again see here. 12 by 90. 6 2s are 12, 6 15s are 90. 2 by 15. 2 by 15. 15 is derived from 3 and 5. 3 and 5. 5 is nothing but terminating. That is the reason one digit is terminating. 3. If the denominator is a power of 5, I will get a terminating decimal. That is the reason one digit is terminating. If the denominator is a power of 3, then it will be a repeating. That is the reason few digits is repeating. This is a concept of mixed decimal. What is a mixed decimal? Mixed is nothing but right terminating plus recurring, terminating plus recurring, terminating plus recurring, terminating plus recurring, terminating plus recurring. Next one. Now we will solve one more question. 0.1033333. 3 is getting repeated. So if a digit is getting repeated, put a bar on that number. So 103 bar. Convert into fraction. After dot, whatever the digit bar is there, write 9. Whatever the digit bar is not there, write it as zeros. 3 is only one digit, so write 9. Dot digit bar is not there, 2 digits are there, 100. After dot, what is the number? 103. Where bar is not there, bar is not there on 10. So answer is nothing but 93 by 900. These nothing but 331s are 300s are 300. 300 is nothing but 3 into 100, 2 square into 5 square. Because 2 and 5 is there, there will be some digits which are terminating. 3 is there, some digits which are recurring. Again, it is a classical example of mixed decimal. I hope it is clear. You can actually check it by using answer options only. You don't need to convert it. Just by looking at the question only, you will come to know that. I will explain it in the next question. You don't need to know how to convert this. You don't need to know how to convert this. Just by having a look at the answer option, you will get the answer. Just have a look at the answer option, you will get it. Have a look at the answer option, you will get it. Sir, how to do by using answer option? Suppose if you want by using answer option, best is you see this question. You see, for example, this question. 9 by 14. 9 by 14. See here. 9 by 14. 9 by 14 is nothing but 9 by 2 into 7. 2 means it should be terminating. 2 means it should be terminating. 7 means it should be recurring. 7 means it should be recurring. So answer should be a combination of. Answer should be a combination of. Are you all with me? Answer should be a combination of terminating plus recurring. Are you all with me? Answer should be a combination of terminating and recurring. It is only terminating. It is only terminating. It is only recurring. Terminating plus recurring. Are you all with me? This is how you can save a lot of time. 9 by 2 into 7. If the denominator is a power of 2 and 5, I will get a terminating. If the denominator is anything other than power of 2 and 5, I will get a recurring. So answer should be a combination of terminating and recurring. It should be, few digits should be terminating, few digits should be recurring. First one, it is only terminating. Last one, it is only terminating. B, it is only recurring. So the only option left is C. Are you all with me? This is the beauty of the concepts. This is the beauty of going through ANC video course. You go through the traditional method, you will use traditional method, and you will feel that why am I not clearing the cutoff? Cutoff you will not clear because the concepts which you know is not in the right way. You are going through a very ordinary method and you keep on writing the examination. I hope it is clear. Still we can do like this. Now see here. 10 by 81. 10 by 81. 81 is nothing but 3 into 3 into 3 into 3. If the denominator is other than power of 2 and 5, what it will become? It will become a recurring decimal. It will become a recurring decimal. Answer should be a recurring decimal. This is eliminated. This is eliminated. Are you all with me? Right? This is eliminated. Now we are stuck in two options. Easily you can say which one is right. 10 by 81. If I assume answer as C, what is that one? 1, 2, 3, 4, 5, 6, 7, 8. After dot, how many digits bar is there? 1, 2, 3, 4, 5, 6, 7, 8. 8 9s I will get. Are you all with me? 3, 5, 6, 7, 8. Cross multiply. What is 0 into 9? 0. What is 1 into 8? 1 into 8? 8. Are the unit digits matching? No. What is the answer? D. 5 seconds it takes to solve this approach if you know the concept. What is the definition of terminating? What is the definition of recurring? Are you all with me? Are you all with me? Kindly reply it in the live chat. Any doubts you got till now? I hope you are enjoying the beautiful shortcuts other than just converting the decimal into fractions. Are you all with me? 10 by 81. 10 by 81 is 10 by 3 into 3 into 3 into 3. 3 into 3 into 3. I wrote 5 threes, it is only 4 threes. I hope it is clear. Kindly reply it in the live chat. Is it clear? Is it clear? This video will be available to only the students. Old students, they can upgrade the package. You will get all the videos which I take. Today evening there is a class from 6:30 to 8 o'clock. Tomorrow there is a class from 10:30 to 12. Tomorrow evening there is a class from 6:30 to 8. Sunday there are 3 sessions. Continuous Anil Nayar's YouTube live classes will happen. Only the enrolled students will get this beautiful package which contains all the shortcuts. Kindly reply it in the live chat if it is clear. Is it clear? Everybody. Raju replied that yes, it is clear to Raju. What about other students? Other students, is it clear? Ankit, I just multiplied by using unit digit beta. Unit digit 10 into 9. Here it is 0 into 9. What is 0 into 9? 0. Unit digit is 0. What is 8 into 1? 8 into 1 is 8. Unit digit is 8. One unit digit is 8. Another unit digit is 0. How can they be same? Are you all? Is it clear? Ankit, what about other students? Kindly reply. Kindly reply if it is clear. Kuldeep will get our Anil Nayar's aptitude course special folder by tomorrow because he purchased the course yesterday. Kuldeep, you will get extra 60 to 80 hours shortcut. I hope it is clear. You can solve like that any number of questions, sir. Now see here. Cube the root of 0.037 bar. Bar is on 3 digits. So it is nothing but cube the root of 37 divided by 999. 37 into 27, which is nothing but 999. 37 ones are 37 27s are. Cube the root of 1 by 27 is 1 by 3. So it is nothing but 0.3 bar, or which is 0.333333. 333333. Right? Any student, if you delay your preparation, right? There are lot of students who purchased the course yesterday. There are lot of students whom I said, please give a call. You can buy it, and still they are waiting for some miracle to happen in their life. Right? I don't think anybody in India, right? Once I get into live classes, it's very difficult for you to listen to other teachers. Only my YouTube, all the YouTube live class videos will be kept in a special folder. Special folder. Only Old students can go for that special package. New students who purchased or who purchased yesterday, that course will be given free of cost. Last few days, those who purchased, right? Students who purchase it today also, they will get the course free of cost in addition to bank and SSC. Now, 18th. Now see here, sir. Square root of 4a square minus 4a plus 1. This is nothing but square root of 2a minus 1 whole square or square root of 1 minus 2a whole square. Both the cases. Both are true. So, this will result in answer 2a minus 1 or 1 minus 2a. Substitute. So, if I substitute 2a minus 1 plus 3a, which is nothing but 5a minus 1. A is 0.1. 0.1 minus 1. Here I got negative value. So, this is not possible. So, here it is 1 minus 2a plus 3a. So, it is 1 plus a. 1 plus 0.1031, which is 1.1039. Answer is 1.1039. I hope it is clear. Answer is 1.1039. Idea clear, right? Next one. Next one. Till now, any doubts? Any doubts till now? Any doubts? Any doubts? No, right? 18th one. No need to apply 2a minus 1. 2a minus 1 is giving you negative values. So, these eliminated. I took 1 minus 2a, 1 plus a. So, answer is 1.1039. 18th also over. 17th over. 16th. How many in the given fractions are rational numbers? Rational numbers means either it should be a terminating or it should be recurring. Either it should be terminating or it should be recurring. Terminating or recurring. 1.45 bar on 4.5, this is recurring. Recurring means it is a rational number. Recurring means it is a rational number. Recurring means it is a rational number. Here it is 1.16 bar. Here again it is a mixed decimal, which is a combination of terminating plus recurring. Terminating plus recurring. Terminating plus recurring, which is again a rational number. Which is again a rational number. There is no particular pattern. 18, 118, 1118, 01001. B and C. They are non-terminating. They are non-terminating and they are non-recurring. Non-terminating, non-recurring. Non-terminating and non-recurring, which is called as irrational numbers. Which are called as irrational numbers. So, how many rational numbers are there? This is a rational number and this is a rational number. Answer for this option is 2. Answer for this option is 2. Answer for this option is 2. I hope it is clear. So, first one is a mixed. Rational number definition is it should be terminating or it should be recurring. Terminating as well as recurring. Terminating as well as recurring. Second is non-terminating, non-recurring. Third one is non-terminating, non-recurring. Third one is non-terminating, non-recurring. Idea is clear, right? Next one. 15th we solved. 14th we solved. 13th we solved. 12th we solved. 12th, let us solve the question. 8 by 27. Now see here. 8 by 27. 8 by 27 is nothing but 3 into 3 into 3. If the denominator is any prime number other than 2 and 5, then it will be a recurring decimal. Then it will be a recurring decimal. recurring decimal. Recurring means this is out. Only recurring it will be. What is this value? See, 0.296. On 96 there is a bar which is nothing but this is a mixed value, terminating plus recurring. So this is not possible. Next one is option B is 0.296 which is nothing but terminating plus recurring, which is not possible. B not possible, C not possible, D not possible. Option A 0.296 bar, which is a recurring decimal. No need to convert fraction into decimals. No need to do school level logics. Just by understanding the definition of if the prime number, if the denominator is a prime number 2 and 5, I will get a terminating. If the denominator is any prime number other than 2 and 5, I will get recurring. If I get a combination of 2 and 5 and other prime numbers, it will be terminating plus recurring. Just by looking at a question itself, you got the answer. Are you all with me? Are you all with me? Clear, crystal clear logic. Just by looking at a question, check which one is recurring and which one is terminating. Which one is recurring and which one is terminating. 12th over. Next one, 11th one. See here, sir. 11th one. I hope the idea is clear. The best thing is, enrolled students, within 2 days, this class will be uploaded as a special folder. In addition to bank prep, SSC prep, there will be a folder named Anil Nayar's aptitude video course. In that one, date by date, the video will be present. You can watch it. Just keep listening to it once or twice. You will get habituated and you will see a tremendous improvement in your score. Point ABC, ABC, ABC. ABC is getting repeated, which is 17 by 37, which is nothing but ABC by 3 digits are repeated, which is 999. Which is 17 by 37. 17 by 37. Now we have to condense it. What is the question that he is asking? 37 into 27 is 999. So I have to multiply by 27. If I multiply by 27, down it is 999. 17 into 27. 27 is 30 minus 3, which is 510 minus 80, 51. 51, which is nothing but 459. 459. What is he asking? He is asking the sum of A plus B plus C. 4 plus 5, 9. 9 plus 9, 18. Answer for the 11th question is 18. Point ABC bar, which is nothing but ABC by 999, which is 17 by 37. 37 to be converted to 999. 37 into 27 is 999. 17 into 27 is 459. 459 represents the alphabets ABC. A plus B plus C is 4 plus 5, 9. 9 plus 9, 18. 11th question also clear. I hope the idea is clear. 9 plus 9, 18. Next one, 10th one. A and B are two single digits, okay, such that point AB, AB, AB is an integer value for all the values of A and B. What is the least 3-digit number? What is the least 3-digit number that n can be? Now if you see here, point AB, AB, AB and so on is nothing but n, which is nothing but point AB bar, which is nothing but n. So AB by 99 into k is nothing but n. N is an integer value. N is an integer value. What is the, and it should be a 3-digit number, and it should be a lowest 3-digit number. Let me take AB by 99 into K is 99. That means K should be a multiple of 99. K should be divisible by 99. K should be divisible by 99. K should be divisible by 99. 199 is not divisible by 99. 108 is not divisible by 99. 999 is not divisible by 99. Only two options are there, 990 and 198. If I take 198, AB by 99 into 198, which is 2 into AB, 2 into AB, 2 into AB. Suppose, what is the least 3-digit number? Okay. I hope it is clear, right? Till now it is clear, right? Question, if it is 198, what is the least 3-digit number? Okay, he is asking for N, not for K. So, here what we will do is, AB by 99 into K is N. So, if I see E is the last 3-digit number, suppose N is 198. If N is 198, I think he is referring to, let me read the question. A and B are two single-digit natural numbers such that point AB and so on is equivalent to N. N is an integer value for all values of A and B. What is the least 3-digit number? N can be. So, N can be. Now, till here it is clear. Let me write down again. AB, and so on, it is N. AB by 99, it is nothing but N. So, what is the least 3-digit number? N can be. Suppose if I take 990, I think here slightly we will change the question. What is the least 3-digit number? Here a small change in the question we will make. Suppose if I make N as 990, AB by 99 into K is 990. Can the smallest 99 into 10 is smallest number. Okay, we will change the question to, otherwise it is becoming, N is an integer. Please change the question. The confusion is whether it is N or K. AB by 99 into K is N. Please rewrite the question. What is the smallest integer value? Smallest integer value for K such that N is an integer. This is the question. Please write down the question, sir. What is the smallest integer value for K such that N is an integer? For N to be an integer, what is the smallest value? That means K should be a multiple of 99. K should be a multiple of 99. So 199 is out, 990 it is out, 108 it is out. Smallest value for K is 198. 198 is 99 into 2. Something is missing in the question, so I just added a few things. Please write down, this is the question. What is the smallest integer value for K such that N is an integer? I hope the idea is clear, right? AB by 99 into something is N. What should be that something? Which should be multiplied by point AB such that N is an integer. So K should be 198. K by 99, so K should be a multiple of 99. K should be a multiple of 99, so K will be 999 is not a multiple. 199 is not a multiple. 108 108 also is not a multiple. I hope the idea is clear. I just changed a few sentences because little it is ambiguity it is giving. I hope it is clear. 10th one, next one, 9th one. X by 0.10. Let me write down this question as x by 1010. Okay, it is recurring. 0.2222, it is also recurring. So x equivalent to 0.10, 10 is getting recurring, 2 is getting recurring, so 2 bar. So this is nothing but 10 by 99. This is nothing but 2 by 9. So which is nothing but 10 by 99 into 9 by 2. 9 ones are 9 11s are, 2 ones are 2 5s are, 5 by 11. 5 by 11. 5 by 11. 5 by 11. I hope it is clear. So 5 by 11, what it will give? 5 by 11, you can check it out. 5 by 11. So it is 0.44444. 11 fours are 44. Next is remaining is 60. 0.45 I should get. 0.4545. I hope it is clear. Very easy question. Answer is 0.45 bar. 0.45 bar. You can also check by using answer option, that also we will discuss, right? 0.45. Now see here, I will do it in method 2. Method 2. We got it as x equivalent to 0.10 bar by 0.2 bar, which is nothing but 10 by 99 by 2 by 9, which is nothing but 10 by 99 into 9 by 2, which is nothing but 5 by 11. So x is 5 by 11. 5 by 11. Option A, which is 0.444, which is 4 bar, which is 4 by 9. Take the unit digit. What is 9 5s are 45, 5. What is 1 4s are 4. 5 and 4 are not matching. Next one, 0.5 bar, which is 5 by 9. 9 5s are 45, 11 5s are 55. These also not matching. Third one, 0.45 bar, which is nothing but 45 by 99. It is nothing but 3 15s are 3 33s are. 33 5s are once. If I take 5 by 11 equivalent to 15 by 33. So which is getting unit digit is also matching. You can also cross check by using answer option. I hope it is clear, right? Converting decimal. Very, very important class which talks about terminating and recurring. Terminating and recurring. Which all the questions which are pending? Let us see. A and B are two single digits. I hope it is clear, right? A and B are two single digits, such that point AB, which is nothing but AB bar, which is nothing but 8 by 11. AB bar is AB by 99, equivalent to 8 by 11. 11 ones are 11 nines are. AB is nothing but 72. A plus B is 7 plus 2, 9. Very easy question. Very easy question. Point AB. Once you know the concepts, then all these are very, very easy. Point AB. AB by 99. AB by 99. 11 ones are 11 nines are. 9 8s are 72. AB is 72. So A plus B is 7 plus 2, 9. 7 plus 2, 9. Answer is 9. 7th. Now these are all these questions which you can easily solve it. 0.15757. 5757 is getting repeated. So it is nothing but 0.157. On that one bar. Bar is present on 2 digits, so 9. Bar is not present on 1 digit, so 0. Original number is 157. Bar is not present on 1. So answer is 156 by 990, which is nothing but 352 divided by 330. 52 divided by 330. Again I am explaining. 0.157. 57 is getting repeated twice. So because it is getting repeated twice, 2 nines it will be present. 990. Original number is 157. 1 is subtracted because bar is not present. 52 by 330. All these are very very easy questions which we have already solved it. Directly I am writing the answer. Directly I am writing the answer for the last question. Now see, 0.123 bar is present on 3 digits, so 999. Bar is present on 3, 123 by 999. Next one, bar is present on 2 digits, so 99. Bar is not present on 1 digit, so 0. Original number is 123. 1 is not, does not have bar, so answer is 122 by 990. 122 by 990. Third one, 0.123 bar is present on 1 digit, so 9. Bar is not present on 2 digits, so 00. Original number is 123. 12 does not have bar, so answer is 111 by 900. 111 by 900. Fourth one, bar is present on 2 digits, so 990. Original number is 102. 1 is subtracted. Are you all with me? Fifth question. Already we have solved so many questions. 102 bar is present on 1 digit, so 900. Original number 102. 10 bar is not present. Here bar is present on 3 digits, 9990. Original number is 102. Bar is not present on 1 digit, 0. I hope it is clear. These are all you can solve it right. Already we have discussed so many of the models. So many of the models. Here it is, bar is present on 4 digits. Answer is 0102. Bar is present on 2 digits, 9900. Original number is 0102 minus 01. Bar is present on 4 digits. Bar is present on 4 digits. So these is nothing but 4 nines, which is 120. Lalit, I will take your doubt better. Bar is present on 2 digits, 9900. So which is 2. Lalit has asked a question. Good doubt, Lalit. It is 123.45 bar, which is nothing but 123 plus 45 bar, which is nothing but 123 plus 45 by 99. Now you can solve it. 123 plus 45 by 99. I hope the idea is clear, Lalit. I hope the idea is clear. Any doubts? Any doubts? Any doubts for today? Please ask me any of the doubts. Any of the doubts? A smart student might also get a doubt. 2.53. I think you might also get this doubt. 2 bar dot 53, which is nothing but minus 2 plus 0.53. If it is 3.42, I think I have already explained, minus 3 plus 42. Minus 3 plus 42. I hope the idea is clear. Any questions pending? Let us see from the first one onwards. First one onwards. Please see here what is, we have discussed all the basic fundamentals. Then we have discussed how to check which number is a rational number or anything. First over, second over, third over, fourth over, fifth over, sixth over, seventh also we have done, eighth also we have done, ninth also we have done, 10th also we did it, 11th we did, 12th we did it, 13th we did it, 14th we did it, 15th we did it, 16th we did it, 17th we did it, 18th we did it, 19th we did it, and 20th also we did it. 20th also we did it. Only fractions and decimals we have done all the problems. A lot of students are messaging me from yesterday. Students who are writing bank exams, students who are writing SSC exam, students who are preparing for MBA prep package, students who are already enrolled. All these packages are available. Here 3500 plus videos are available. Here 4000 plus videos are available. In MBA prep package, 4500 plus videos are available. Plus 600 plus tests are there. Plus 650 plus tests are there. 700 plus tests are there. And the best thing is, all the students who purchase Bank, SSC and MBA today, they will get 80 hours of Anil Nayar's new YouTube shortcut videos. YouTube shortcut videos absolutely free. If you buy it today, you will get these 80 hours absolutely free. Old enrolled students, you can upgrade for these 80 hours of Anil Nayar's new YouTube content by paying 3000 rupees. Please WhatsApp again right after the class. Every class I give some good discounts to the students who are spending time. 80500 67891. Kindly WhatsApp me if you are from an old enrolled student. WhatsApp this number, right, for any of the packages. Our content is dynamic. It will keep increasing. I will say less, I will do more. Aptitude, reasoning and verbal. Right? In aptitude, after 15 days, if you find any better shortcuts anywhere in India, in terms of the maximum number of shortcuts, right, I'll pay your fees. Right? Most of the top teachers have actually buy our course. Just because I am not coming online, they showcase their course. Interested students who want to crack bank exam or SSC exam or MBA prep package or placements, anyway, this is my number. I am already available to you. Old enrolled student, from today evening onwards, this package will cost 4000 rupees. In case if you are an old enrolled student, save 1000 rupees by immediately WhatsApping me. You can WhatsApp this number. The first 5 students, anyway, you will get a huge discount. Every day after the class, first 5 students, they will get a discount. Yesterday, enrolled students, total 80 plus students have upgraded the package because they know that every time Anil sir takes the class, the content will be new. Thanks a lot, sir. Thanks a lot. What you have to do is, immediately, this class will not be available. In case if you want to upgrade the package, if you are an old enrolled student, you can WhatsApp this number. In case if you are a new student, 8296989020, you are struggling to pay your tuition fees. If you want a discount, just because you want the things, the first 5 students, you can watch it in laptop, you can watch it in mobile, you can download the videos in mobile, Android mobile. We will cover aptitude, reasoning and verbal, all inclusive. Old student can upgrade it. Only my shortcut videos at 3000. You want the complete package of bank, SSC or an MBA prep package or a placement package. First 5 students, either you can message this number. If they are not available, message me in case if you want to directly speak to me. Thanks a lot, sir. Evening again 6:30 we will attend the class. I hope you all enjoyed the class. Thank you. I think to all the 4 students who have messaged me, please wait till I close the class. You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, ANC.